as we have discussed in the previous episodes of Kubernetes, that Kubernetes is just a container orchestrator and it cannot make containers by itself. So it just manages the containers. So the entity which makes the containers, that is the container runtime, is the main focus of these bonus episodes. There are different kinds of container runtimes, but the one that's most popular and the one that would be discussed in these bonus episodes is Docker. Containers are hugely helpful for improved security, scalability, and reproducibility across different cloud providers or even your workstation. Docker is a platform to develop, deploy, and run applications inside containers. Docker is essentially synonymous with containerization. Before we go further, these bonus episodes are heavily inspired by the Medium article titled "Learn Enough Docker to Be Useful." So just check it out. It's a very good article. A Docker container holds things. Something is either inside or outside the container. It is portable. It can be used on your local machine or cloud provider servers. Docker container has several mechanisms for interfacing with the outside world. It has ports that can be opened for interacting through the browser. You can configure it to interact with data through the command line. Docker container can be obtained from a remote location. An offsite registry keeps an image, which is like a mold for your container. Then when you need a container, you can make one from the said image. So this offsite registry is provided by Docker. It's called Docker Hub. You can also have your own Docker registry if you so choose. In addition to the container metaphor, you can think of a Docker container as a software program. At its most basic level, a container is a set of instructions that manipulate other bits. While a Docker container is running, it generally has programs running inside it. The programs in a container performs actions, so your application will do something. For example, the code in a Docker container might have sent you the content you are reading on a web page. Or it might take your voice command to Amazon servers and decode it into instructions which could be used by a different program in a different container. With Docker, you can run multiple containers simultaneously on a host machine. And like other software programs, Docker containers can be run, inspected, stopped, and deleted. Now let's discuss some Docker concepts, starting with Docker image. A Docker image is more like a blueprint. Images are immutable, that is used to pump out containers that are exactly alike. An image contains the Docker file, libraries, and the code your application needs to run, all bundled together. Then comes Docker file. A Docker file is a file with instructions for how Docker should build your image. The Docker file refers to a base image that is used to build the initial image layer. Additional layers can then be stacked on top of the base image layers according to the instructions in the Docker file. For example, a Docker file for a machine learning application could tell Docker to add NumPy, Pandas, and scikit-learn in an intermediate layer. Finally, a thin writable layer is stacked on top of other layers according to the Docker file code. A Docker image plus the command docker run image name creates and starts a container from an image. Now let's look at the Docker terms, which are essential. Docker platform is the first one. So Docker's software that provides the ability to package and run an application in a container on any Linux server. This platform bundles code files and dependencies. It promotes easy scaling by enabling portability and reproducibility. Docker engine. It's a client-server application. The Docker company divides the Docker engine into two products. The community edition, which is free and it's based on largely open source tools. It's probably the one that you'll be using. And the other one is the Docker Enterprise, which comes up with additional support, management, and security features. But we'll most probably stick to the community edition. The Docker client is the primary way you'll interact with Docker. When you use the CLI, that is the command line interface of Docker, you type a command into your terminal that starts with the word Docker. Docker client then uses the Docker API to send the command to the Docker daemon. Docker server that listens for Docker API requests is the Docker daemon. The Docker daemon manages images, containers, networks, and volumes. Docker volumes are the best way to store persistent data that your apps consume and create. Docker registry is the remote location where Docker images are stored. You push images to a registry and pull images from a registry. You can host your own registry or use a provider's registry. For example, AWS and Google Cloud have registries. Docker Hub is the largest registry of Docker images. It's also the default registry. We can also find images and store your own images on Docker Hub for free. Let's look at Docker repository. These are collections of Docker images with the same name and different tags. The tag is the identifier for the image. Usually a repository has different versions of the same image. Now let's discuss Docker networking, which allows you to connect Docker containers together. Connected Docker containers would be on the same host or multiple hosts. Docker Compose tool makes it easier to run apps that require multiple Docker containers. Docker Compose allows you to move commands into a docker compose.yaml file for reuse. The CLI makes it easier to interact with your multiple container app. Docker Compose comes along with the installation of Docker. Docker services are the different pieces of a distributed app. Docker services allow you to scale containers across multiple Docker daemons and make Docker swarms possible. Now let's discuss a bit about Docker images. Docker container is a Docker image brought to life. It's a self-contained, minimal operating system with application code. The Docker image is created at build time and the Docker container is created at runtime. The Docker file is at the heart of Docker. This Docker file tells how to build the image that will be used to make containers. Each Docker image could contain a file name called Docker file with no extension. The Docker file is assumed to be in the same current working directory when the Docker build command is called to create an image. Container is built from a series of layers. Each layer is read-only except the final container layer that sits on top of the others. The Docker file tells which layers to add and in which order to add them. Each layer is really just a file with changes since the previous layer. In Unix, pretty much everything is a file. The base image provides the initial layer. A base image is also called a parent image. When an image is pulled from a remote registry to a local machine, only those layers that are not already on the local machine are downloaded. Docker is all about saving space and time by reusing existing layers. A Docker file instructions are a capitalized word at the start of the line, followed by the arguments. Each line in a Docker file contains an instruction. These instructions are processed from top to bottom when an image is built. Only the from, run, copy, and add instructions create layers in the final image. Other instructions configure things, add metadata, or tell Docker to do something at runtime, such as expose a port or run a command. With Docker files, there are often multiple ways to accomplish the same thing. The best method for your case is a matter of balancing Docker conventions, transparency, and speed. For example, run, CMD, and entry point serve different purposes and can all be used to execute commands.